that we followed while compiling this project. We undertook multiple stages of research and analysis and identified the issues that exist in the freshwater management. Inspired from the space community, we made efforts to compile a best practices guide that brings together interdisciplinary aspect of space to help the freshwater management community. First, we saw the hydrological cycle, the cycle that sustains life on Earth. It seems a simple cycle, but actually it is very poorly understood even by the scientific community, and this makes it even more difficult to predict its patterns. And over the past few centuries, it has undergone various changes. We saw the global freshwater situation, and we found that most parts of the world have limited freshwater resources, and these limited freshwater resources are depleting rapidly. We investigated the factors for this freshwater depletion, and we saw that climatic changes, deforestation, coupled by human factors such as globalization, over-extraction, lack of resources, corruption, and conflicts between the nations sharing the water resources are the main factors. As a part of our project, we did a literature review, and in that, we did a global survey where we found that most of the developing nations as well as the developed nations face most of these problems. And some of the most recurring factors that we found were poor sanitation, climatic conditions, and conflicts due to shared water resources. So our team decided to focus our efforts to address the transboundary water sharing issues. And there are several reasons to do this. For first, the transboundary water sharing issues is a widespread concern, and it has led to armed conflicts between the nations. Moreover, the topic for climatic changes, poor sanitation, and deforestation, etc., is a resource-saturated area. And space assets have been considerably used to mitigate these factors, but transboundary water sharing issue is a relatively new area. We'll see some examples of transboundary water sharing issues between different nations. The River Nile Basin, shared by 10 countries of Africa, is the epicenter for conflicts for most of the nations. The upstream nations are undergoing globalization and they want to increase their water allocation, but they have failed to decide upon a common management plan, and this has led to conflicts. The downstream nation of Egypt that sustains on Nile is under threat because of Ethiopia's efforts to build dam and to block the water. So both these nations are under non-negotiable ends. Lake Chad in Africa. This has diminished in its size from size of Spain to size of Denmark in its past 5 decades. And people from Nigeria have migrated to Cameroon, and this has led to clashes between the nations. The Tigris-Euphrates Basin, shared by Iraq, Turkey, and Syria, is the tension for all the 3 nations. The space applications are considerably used in this area, but the data that is either not available or is not discussed for management. As a part of the team project in ISU, as summer space studies, in 2009, the HOPE report gave some recommendations to solve these problems in this basin. But all situations are not the same. We see the River Danube Basin. This is shared by 19 countries of Europe, and they have agreed upon a common management plan to protect this basin and to repair the damages done in the past. And space assets have played a pivotal role in this. So from our research, we found that the main problem is high demand and low supply. And from the different situations that we saw, we identified the problems into 3 categories, into 3 scenarios. For the first scenario, we saw that the demand of the nation exceeds the supply, and there is no ability to negotiate with its neighbors that share the common resource. and the nation has no other method to increase its water supply. For example, Egypt and Ethiopia sharing River Nile. In the second scenario, the demand of the nation exceeds the supply, and there is no ability to negotiate with its neighbors. But alternative sources may be present, which are presently unfit for human utilization. For example, the Tigris-Euphrates basin, where there are underground water table which is yet unused. In the third scenario, the demand of the nation exceeds the supply, but there is ability to increase the supply via international agreements with its neighbors that share the common resource. Alternative sources may or may not be present. For example, the upstream nations of Nile that have failed to establish a common basin management plan. For each of the scenarios, our team proposes solutions. Solutions for the first scenario, we recommend that the nation should improve its water utilization efficiency through space technology and application. In the second scenario, our team recommends that the nation should improve its water utilization as well as identify alternative sources to increment its supply via space applications and technologies. And for the third scenario, in addition to increasing its water utilization efficiency, as well as if alternative sources are present, it should be identified, but taking best practices from the space community, the nation should negotiate with its neighbors and agree upon common management plan. And each of the solutions build upon one another. So to select our best practices, we had a methodology. For the methodology, we took the freshwater management community and the space community and found out the solutions and the services that could be implemented. We saw the countries that experienced conflict due to shared water resources and intersected it with the space practices that can help the water management community. From this, we defined the requirements that are needed and saw if the solutions are available. If the solutions are available, we move to where, how, and to whom can we implement these solutions, and finally come to the best practice guide. If the solutions are not available, we see what is the problem and how can we solve it, which leads us to the capacity building to reach out to our end users, and finally compile the best practice guide. The final deliverable of our project is the best practice guide. So we proceeded in a very holistic approach, taking the multidimensional aspect of space disciplines, such as the space engineering and human spaceflight, the space science and space applications, space politics, business management, and the space humanities and outreach. Each of the disciplines were integrated and each of the scenarios were addressed. Finally, we give an interdisciplinary set of recommendations of how we can implement the best practices for the specific scenarios. This is also the structure for our Blue Marble report, which you can get it from the ISU website. And the further best practices and recommendations will be explained by my colleagues. I pass on to the floor to Juan.
Thank you, Shreya. So, as just a small question to recall what we heard. Through how many countries rely on the Nile for water resources? 10. Imagine that. That is the aim of our project, for those 10 countries to come together and share the water resources. This is very important. This slide is very important for here today because all the presentation is going to be divided into these 3 scenarios that we identify from these places. So now, to continue with the engineering best practices, I will pass the floor now to Matteo.
Thank you, Juan. Welcome to everyone. I'm Matteo from Italy. And for this first part of the best practices, I would like to introduce you to the first technical of the session. It's about engineering and human spaceflight mainly. A few words on how we proceed to identify our solutions. 2 ways, direct and indirect solutions. What do we mean by that? Is that direct solutions are the ones developed and used in space, while indirect have been developed during space studies but have not been implemented in the space sector itself. We went through a selection process based mainly on the availability of best terrestrial alternatives, high technology and cost limitations, and in general trying to find the best fitting to the three scenarios that Shreya presented to you. In general, the outcome of these can be summarized in this form. So there is an understanding of the daily water requirements, how to implement closed-loop system and water purification systems, and they use the non-conventional water resources. Starting from the beginning, what do we mean by understanding daily water requirements? Human physiological needs have been studied in the space sector since the beginning of human space flight. As you can see here, there is a summary in this table. There you can see that the requirements for oxygen and food are more or less the same on Earth and space, while for water there is a huge difference. This is mainly due to the different activities that we conduct in space and on Earth. But what's the outcome of this? Here you see another perspective of it. You have input and output to sustain a human being. As you can see, the additional water that you use for activity on Earth is a key aspect for the use of this water. The outcome of all our reasoning was that if we want to tackle efficiency, we have to know where we have margins to tackle them. We cannot act on sustaining the human beings, but we can tackle on the activity or the additional activities that we do. So the outcome of these is even for the first scenario. The first scenario is about efficiency, and so we recommend the intensive use of the physiological needs derived from the space studies for human space flight that can give us the area to tackle for efficiency. Moving forward, we consider in general life support system for use in space. They are very interesting, and a key part of that is related to the water treatment. Now, we look mainly at closed-loop systems due to the fact that they are the most, they can maximize the efficiency project. As you can see here, this is a scheme of the general water recycling system of the International Space Stations. The first outcome that is clear from this graph is that each single element of this is connected to the others. So a small change in one single element can influence all the others. The first outcome is that we want a systematic approach to a water basin. If we use a systematic approach to a water basin, we can improve the overall efficiency and decrease some of the risks related to that. In a more technological way, here you can see a concept of an eco-house. An eco-house is an house that is supposed to be independent from the general infrastructures in terms of water and energy in general. The main limitation of this concept is related to the high cost of technologies. We think that through technology transfer, space can provide cheaper, high reliability components to enhance this type of concept and then improve the overall efficiency at household level. And this exactly follows the discussion that I was telling before. It's tackling efficiency again, and it follows in the first scenario. The third aspect that I want to point out is related to water purifications. Water purification has been done on Earth for centuries, but the space sector has specific challenges that needs to be tackled. Here you see a summary of different purification technologies developed in the space sector during the years, and there are studies ongoing now. I will give you a first example, just an example of what I mean when I say about indirect solutions. Here you can see a beautiful flower. This is a water hyacinth. NASA Stanley Space Center developed the technology of water purifications based on this flower during the study for human settlement in other planets. This method is not used in space yet, but on Earth is still used in the Stanley Center water recycling system itself, and is used also on the Disney World in Florida as example. The implementation of these technologies have two main outcomes in our framework. First of all, allow the country to use sources that are not being used because polluted or other reasons. And second of all, it can help upstream, downstream country situation, allowing a reuse of the same resources. The last solution that I want to propose you is the use of non-conventional water resources. In general, there are different methods to tackle them. Here you can see that we classify them in terms of the energy cost and the availability of fresh water for the specific region that where we want to implement the system. In general, conventional methods requires an high availability of water and the low cost of energy. I will talk a bit more about atmospheric condensation due to the position in this table, which is very interesting. Atmospheric condensation has been used in space for decades at this stage in the life support system for manned spaceflight in general. As example, the ISS atmospheric condensation system provided 39% of the total water consumed on the ISS in the last 14 years. The principle is to extract water from the humidity present in air. Most of the technologies used on Earth are space-derived or are similar to the one used in space. So the implementation of these methods can improve the situation in one of our scenarios. Specifically in the second scenario, we are looking for something new. We have some resources, but we are not able to exploit them. This is one of the ways in which you can exploit them. To conclude, we went through this process of selection, and we cut off some of the solutions that we identified. In addition to that, we identify some constraints and challenges. In general, when we talk about technology transfer and spin-offs, there are always development costs and technological challenges that can be faced. In addition to that, we have some ethical consideration here, especially when talking about purification of water. Purification of water is a critical aspect, is an ethical aspect in some culture, because we have to be ready to and willing to use a source of water which was contaminated before. And so these challenges have to be overcome, but the benefits will be high for everyone. And with that said, I will pass back the floor to Juan. Thank you.
Thank you, Matteo. So these are the engineering aspects from our project. As you heard, from the human performance in space, the human consumption of water in space is minimal. Okay, they don't take a shower, but every time that we take a shower for an hour, let's think about that. Let's think about this crisis. Let's think about the water problem, because it is a real problem. And it is for us here, for the viewers there, to change that. And with that said, I would like to pass the floor to Mariu, who is going to talk to you about the space applications aspect.
Yes. Thank you, Juan. Good afternoon, everybody. I'm Muye from China. In this section, I would like to introduce the space applications. With the introduction of Earth observation satellites, the remote sensor technology became a very important tool for hydrological study and water management. So in this section, I would like to introduce the four best practice of space applications. The first one is monitoring land use, which means to improve water use efficiency. There are many spectral bands can be used to estimate the land use, such as near-infrared, mid-infrared, visible spectral bands, and or multispectral imagery. At the same time, with the specific remote sensing algorithms, some important crop parameters can be achieved, such as evapotranspiration, NDVR, NDWI. Now I would like to introduce an example. From this figure, you can see that this figure gives the total evapotranspiration level for different land use patterns. From this figure, we can see that the irrigated crops have the highest evapotranspiration levels, which can be used to identify land use. So we suggest that analysis of land cover and agriculture by using satellite data to improve water use efficiency. For example, some accurate information such as the evapotranspiration I mentioned before is critical to assess how much water is needed for different land crops group grass phases. And with the introduction of such practice, the sustainable use of water, available water is promoted. And the next one is monitoring water quality, which means to improve the efficiency of water management. The high resolution remote sensor data, GIS, in combination with some computer modeling, provide a good practice to monitor water quality, such as the turbidity, suspended matters, and so on. At the same time, the multispectral imagery obtained from high-resolution data also can be used to detect water leakage, especially in the agricultural land. Since suspended metal play a vital role for monitoring water quality, this figure shows the total turbidity patterns of part London of River Thames, which is captured by Landsat. And this information can be used to estimate the suspended matter distribution, and then can be used for monitoring water quality. So we suggest to monitor water quality, to detect water leakage by using satellites to improve efficiency. And these methods can also be used by water management authorities to implement targeted strategies. The third one is identify new water sources. In many areas, as we know, the fresh water is available but inaccessible. In such a scenario, remote sensing satellites can be used to identify new resources. And today, there are already many missions and organizations are involved into such practice, such as the GRACE mission, the Grand mission, NASA, and other satellites and organizations. I would like to show you another example. This figure shows the subsurface freshwater distribution of America, which is captured by GRACE satellites. And the point is that this figure gives us the opportunity to visualize and model the subsurface freshwater supplies of America, which is very useful for identifying new water sources. So we suggest identify underground sources using satellite data as the basis to develop appropriate exploitation techniques. With the introduction of such practice and technologies, we can obtain the sustainable water management at all levels. Okay, the last but not the least is mapping waterfall transparency, which means to make use of remote sensing technologies to map shared water across nations. This includes the total amount and the distribution of data, usage, efficiency, and quality of data, and also some case-specific regional or time-dependent data for further and long-time research. But today, there are only a few application examples in such domain. For example, the projects initiated by International Water Management Institute and ESA's target project. This picture is an example of ESA's target project, which shows us an integrated image of Zambia River. From this figure, we can see that we can get the information such as the hydrological networks and the main water infrastructures. Now, I would suggest that Earth observation products can be as a basis for agreement in a scenario where shared water is present. And with the introduction of such products, we can create trust and transparency across nations, and also we can assess water distribution, availability, usage, and quality over a region, both at the national or at the basin level. Now, I would like to conclude my talk. In this section, the 4 basic practices cover all scenarios were introduced. And then the further suggestions on how to implement such solutions were made. And all of this can be a good examples for the future water management, especially for the transboundary water management. Thank you. Now I would like to pass my floor to Juan. Thank you.
Thank you very much, Manuel, for that. So now that we've seen the space applications aspect of our project, just a small question. Since when have we had space-based Earth observations? Since the 60s. Since the 60s. It's been 50 years. And well, not 50. Wait. Yeah, it's been many years since there. And in Guatemala, we still don't use it. We still don't have it in for our use. So it's for us to bring that. With that said, I would like to pass the floor now to Yadvinder, who is going to talk to you about international relations and cooperations.
Thank you, Guan. I'm Yadvinder, and I'm from India. So I'll be talking about and giving you a brief introduction about the best practices that come from the space sector based on space law, politics, economics, and management and business models. And we'll see that how these frameworks and these models can be implemented in managing the fresh water resources while considering the transboundary river basins. So I'll be specifically concentrating my talks on 3 topics: the Outer Space Treaty and the Moon Treaty, the International Telecommunication Union, and lastly on the International Space Station Management. Starting with the Outer Space Treaty and the Moon Treaty. So both of these treaties have introduced 2 concepts in law. The first one is common goods, and second one is common heritage to mankind. So starting with the common goods that is being introduced by the Outer Space Treaty. This treaty is also serve as the basis for the space law. So to understand the concept of common goods, first we need to understand 2 variables. The first one is the non-excludability, and the second is rivalry. So non-excludable goods are those goods. So if one utilizes that, it is impossible to exclude anyone from utilizing that good. And the concept of rivalry means if one is utilizing a particular resource, he is not precluding anyone from using it. So a common good is both non-excludable as well as rivalrous. So outer space is listed as a common good. It is interesting to know that the cyberspace and the atmosphere are also considered as common good. Now with the discussions that Shreya had about the global water cycle, it is logical that if we define freshwater resources as common good, because water across the globe is connected through the global water cycle, but that's not the case, because specifically for the transboundary river basins, the damming of rivers by the upstream nations are excluding the downstream nations from utilizing the same amount of water as they are using it. And also, if we implement the concept of common good at an individual scale, we'll encounter a problem known as free rider problem. That is, if there are no restrictions and each and every individual is provided equal access to water resources, then of course they will overuse it. The demand for that resource, for the freshwaters, will be much higher as compared to the limited supply. So these are the factors that we have to consider while drafting a legal basis for freshwater resources. The second concept is common heritage of mankind. That is nothing but a more restrictive legal basis for access, management, and exploitation of a resource. Now the Moon Treaty categorizes the resources on Moon as common heritage to mankind. Now one might argue that if majority of nations are not coming forward in safeguarding the resources of Moon, then how can we expect them to come and safeguard freshwater resources as common heritage to mankind, as it's much more restrictive? But also it is the UN resolution for sea, which categorizes the deep sea bed as common heritage to mankind, is being accepted and signed by 160 countries and ratified by 60. Also, some of the parts of Antarctica are also considered as common heritage to mankind. So we have seen that both of these treaties and these concepts have strong ethical considerations. So our team recommends that while defining the legal basis of freshwater resources, we should consider both of these resources from these treaties, and we recommend that while drafting the the legal framework for transboundary water management, these concepts should be considered. The next thing is International Telecommunication Union, which is one of the most successful organizations in human history. It has 193 countries and over 700 private institutions as its member. So this organization allocates the slots in geostationary Earth orbit and the radio spectrum to various nations. So both of these resources are considered to be limited and hence share a resemblance with the freshwater resources. So our team recommends the ITU model of management should be considered while we plan a management model for water resource management. Coming to the International Space Station, which is one of the most expensive and complex single structure ever built by humankind. So based on the costs involved for the manufacturing and operations of International Space Station, it is not possible by a single country to build a machine of such size. So it involved two of the major spacefaring nations, US and Russia, to set aside their different political agendas and come together in building this station. So it involves various legal frameworks which consist of intergovernmental agreements and various MOUs between various space nations. And despite the recent sanctions by US and various other countries against Russia for the annexation of Ukrainian territories, the operations for the International Space Station remain unhindered. So this shows the level of commitment that various nations are showing towards the success of this project. So our team recommends the framework of international cooperation that underpins the International Space Station should be considered while creating agreements for shared freshwater resources. And concluding my talk, I would like to say that while defining the legal basis of freshwater resources, specifically for the transboundary river basins and other resources, the lessons learned from both of these concepts, common goods and common heritage to mankind, that are introduced in Outer Space Treaty and Moon Treaty should be considered. Also, the management model for International Telecommunication Union and International Space Station should be considered while drafting the framework for cooperation and consensus at an international level for freshwater resource management. And the biggest learning outcome from this talk is, irrespective of different political conditions, economic and scientific developments, all the nations should come forward for the betterment of mankind, leading the world together towards a better future. With that said, I would now pass on the mic to Kwan. Thank you.
Thank you, Yadvinder. So as you can see, space has to offer also in managerial and policy aspects. And now I would like to pass the floor to Melissa, who is going to talk, to inspire us on how to outreach these ideas.
Hello, everyone. My name is Melissa. I'm Colombian American, and I will be speaking to you today about the humanities aspect of this project, specifically outreach. As Juan spoke about at the very beginning of the presentation, the blue marble image is a good starting point for thinking about global water issues. It evokes feelings of unity, of fragility. It makes people feel and it makes them care. So it is with a lot of purpose that we place the humanities section at the end of our report and our presentation. It is the linchpin of all the rest of the solutions. The best practices that I will speak about are not only best practices on their own from the space community, they are also essential for the implementation of all the other solutions my colleagues have spoken about. In order to successfully implement any type of solution from any discipline, you must consider how to effectively get those solutions to the water manager. And when you look at this globally, the water manager might look very different in different places. In some places, a water manager is a government, it's a company. In other places, it might be an individual who goes out and digs a well and extracts water for his or her family. And when you're talking about sharing water between places where this water manager looks very different, then it can be complicated. Our outreach method, therefore, went in two directions. We looked both within the space community at artistic and social methods of outreach, formal and informal education, professional outreach, and official celebrations such as World Water Week and World Space Week. We also wanted to look at different cultural methods of outreach. As Matteo was speaking about, if you might have a water purification technology, but if your user isn't going to use recycled urine to bathe before prayer, then it's not an effective solution. So we looked at it in both directions. And from that survey, we came up with 4 best practice outreach solutions from space. Those being social media networking by space agencies such as NASA and ESA, the development and the use of mobile applications, the offering of prizes and competitions for water technologies, and the use of space art to both raise awareness and funding for water issues. The first best practice is the use of social media by space agencies. NASA, for example, has platforms such as Facebook and Twitter they use, and ESA makes good use of video platforms such as YouTube. This past year, they had the creative film Ambition for the Rosetta mission. I watched the short film and I thought it was a trailer for a feature film at first, and then was extremely disappointed when I found out I would never get to watch this feature film. So it engaged me. It left me wanting to hear more about the mission and see more in this video form. NASA and ESA have also designed a package they call a Comet Landing Social Media Kit for the mission, which includes not only a Comet Landing hashtag they can put on Twitter, but also segments of these cartoons featuring a very cute Philae and Rosetta that you can tune in segments and follow along with the mission. There's also a Facebook avatar for Philae, and so you can befriend him online and also follow the mission through that. So these agencies are making very good use of social networking, but little is used in these forms for water issues. The team recommends that these sorts of methods can be used to sensitize the public in order to decrease water efficiency, and also to reach management institutions, which will increase transboundary sharing. The second solution we looked at was the use of challenges and camps by space agencies, which encourage the development of mobile applications. NASA and ESA both do this globally, and they gather together people who create both innovative and open source mobile applications, some of which have been focused on water already. The team suggests that these organizations combine with other organizations such as the One Laptop Per Child, which could then use these interactive systems developed by space agencies to reach the youngest water manager. As Mengyue was speaking about, we have a lot of space data that can be used to manage water. But if that data doesn't both reach the end user and the end user doesn't know how to appropriately use that data, then it's worthless. So the team recommends the following integrated system, which is inspired by a system already in practice in India. Data, all sorts of different data, including space data, but also socioeconomic data, as in the Indian system, will be fed into a global database, or at least an international one. This database will be accessible to the challenges and camps and competitions that I spoke about, so that mobile apps can be developed to utilize that data. Those applications will then be fed to specialized sources, so they can be used for purposes such as education or professional use. For example, in India, farmers use this data on a daily basis. So these infrastructures, these mobile app infrastructures, are incredibly important because we have an abundance of data, but still not users who recognize that value. The third solution that we looked at was the offering of innovation prizes for water technologies. These are two examples connected to the space community. The X Prize and space tourist Anusha Ansari. This prize offers an environmentally focused prize which has been awarded to water technologies. There's also the Prince Sultan bin Abdulaziz International Prize for Water, which is very connected to the space community and awards global prizes for water. These two examples are special because they come from a region that is stricken with physical water scarcity. So the system interacts globally with these technologies, which can then feed solutions back into the country. So the team recommends that governments and space agencies sponsor these types of programs. Not only do the technologies increase water efficiency and the identification of unknown sources, but they also encourage global collaboration. The fourth and last solution, which I will talk about, is the use of space art to raise both funding and awareness on these issues. And the best example from the space community of this framework is that of Guy Laliberté, a circus performer and space tourist who spent 2 weeks on board the International Space Station photographing the Earth's surface as part of what he called a poetic social mission aimed specifically at increasing awareness of global water issues. He then sold his art in book form and exhibition form, and that money was then funneled into a nonprofit organization of his own called the One Drop Foundation. To summarize this complex yet incredibly elegant framework, there is space art, art created in space, which is sold, raising both awareness and funding, and that funding is then used to actually put into practice solutions in regions of the world. Laliberté also uses the Cirque du Soleil franchise to have one-night performances. As you can see, they are water-themed and raise awareness primarily in developed countries, but all of the funding from these performances are funneled into the nonprofit, which implements solutions mostly in developed countries. So the artistic event can be applied to all three of the scenarios. They can make people feel and think about the fragility and the beauty of our Earth's surface, and they can raise awareness about untapped water resources in people's country and abroad. And they can also increase collaboration and awareness of transboundary issues. So in conclusion, the space community is connected to the water management community already by these solutions, but the team sees substantial ways that that can be developed and increased. Key to all of the outreach solutions, and therefore all the solutions that we've talked about today, is human investment and human agency. An effective platform for these outreach solutions could potentially be the World Space Week, which every other year focuses on in-Earth problems. And if you want to read further in our report, we suggest ways that these outreach solutions can be implemented on that platform. Thank you.
Thank you, Melissa. And as you have seen, the humanities part is a very important part of our project, as this is a man-made problem, and the solution has to be man-made as well. So now, connecting all the dots from all the solutions and how to implement them, we're going to finish, have some recommendations.
Thank you again, Juan. So we are coming to an end of this presentation, and I would like to show you what do we mean by a recommendation here. Basically, our recommendations are an how-to-use guide for all the solutions for the implementation of the various solutions that we presented today. These are not considered definite single solutions, but represent a framework. We can apply them case by case, taking account of additional constraints. In addition to that, they are not thought to be self-sustaining in each scenario. They are building on each other, scenario after scenario. And I will try to exemplify that in this way. The first scenario is a situation in which the demand exceeds the supply. We have no opportunity to increase our resources through cooperation, and there are no additional resources in situ. This is the set of solutions that we propose. Now, let's see how they work together. The key word is efficiency. We say that we have to increase efficiency because the only way to match demand and supply. First of all, I was telling you how space can help understanding the real needs and so targeting the actions. In addition to that, we have tools to control and monitor our use. But all the technological solutions, as Melissa was saying, are nothing if we don't have users implementing them, especially in a situation in which efficiency is important. Water is used by everyone. The user, the end user, has to be efficient, first of all. And the end user has to be aware on how to be efficient. Moving forward, the second situation is a similar situation. But in this, the difference is that now we have in situ resources that have not been exploited yet. As you can see here, the solutions we propose for efficiency are still present, and we added the one for finding new sources. How is that? Water is a limited resources. If we are not efficient, we shouldn't use new sources. If we are not efficient on what we have, we shouldn't increase that, because it's a limited resource and we have to move forward. Here the keyword is growth. We want to increase our supply. Now, there are a lot of methods that can be derived from space to use different sources. These are innovative methods, etc. And so innovation is growth. But innovation has to be known, because otherwise, if these new methodologies cannot be implemented. So here again, the importance of sharing the knowledge, increase the knowledge of the end user is even more important. Coming to an end, after being efficient in all the use of all the resources present, a country has strength now. We can act in search for cooperation and look for cooperation. We can look for that. We are efficient with what we have. We are using all that we have. Now we have a strong position to act in the search of cooperation. Now the picture is complete. This is clear. The key word is cooperation. We have tools. Mengyu was telling you about an Earth observation-based map of a basin, which includes a lot of information that can help managers to better manage the shared resources. In any case, cooperation requires a shared set of principles, common goals, and understanding of needs. So the space sector can provide some insight on that in terms of experience that gained through all the cooperation during these years. In addition to that, we know that cooperation is not easy. It's never easy. We will face a lot of challenges, and we have to overcome a lot of obstacles. One message that we want to pass today is that water as space knows no border. That's very important for us. It's been a message that Melissa tried to put forward. There are a lot of tools to pass this message, and this message is in two ways very important. First of all, can boost the process for starting a cooperative framework. And second, can be a memento to overcome difficulties during the way of cooperations. So that ends the recommendation section, and now back to Juan to conclude this presentation. Thank you.
So now, just to finish up with some conclusions of our whole project and the presentation. So, a fraction of the water has to be shared among the world's population. As I've said already a couple of times, this is a man-made problem. We created this. We created this problem, and there are lots of issues related to water. But space can do a lot. The Global Water Initiative, which is our project, and has students from all continents except Antarctica, of course, because there's no one there. But well, there is. The Global Water Initiative identified 3 scenarios, and we came from an interdisciplinary approach and provided solutions from various disciplines, which are comprised and compiled into a best practices guide, which is the outcome of our project, and you can find it on the internet. If you go through to the ISU website, isdunet.edu, then you go to the ISU library webpage, and in there, if you search Global Water Initiative or Blue Marble, you will be able to find the rest of our project, because this is just a glimpse of what we did. Just a small glimpse of our project. But so with that said, I would like to conclude, and I would like to thank you all for listening, surviving through this hour, and I would like to call now my teammates for finishing.
Okay, thank you very much for a very accomplished presentation. I was very impressed both by the activity in the room and also the social media activity at the same time. So I think that's a first for a master's team project. I'm now going to start to send the microphone on a little trip around the assembled faculty here, who will answer your questions. We've got about half an hour now for questions, but we have a number of faculty, so keep your answers kind of focused. Thanks.
First of all, congratulations on a fantastic presentation. You did a great job of introducing the context and the scope of what you were trying to do. It came across very clear. I was very impressed. I have, as always, numerous questions. And some of them are quite detailed, but I'll just pick a few choice ones. You've identified various space technologies that are going to be potentially transferable to help water conflict-stricken places in the world. How scalable are these technologies? Have you addressed how scalable they are and whether or not they're practically implementable? You gave the example of atmospheric recondensation as a potential technology. Is this something that where the systems we use on the ISS can be implemented in a large scale here on Earth?
Thank you for the question. So the question is on how scalable are the technologies that we proposed.
Thank you, Dr. Osborne. I'd love to address that question. So we did look at the scalability and to take in the atmospheric condensation example. Systems for atmospheric condensation are actually already used in several countries. Guatemala, for example, does have one system in use. The system that's actually used on the ISS, we wouldn't directly implement. That involves compression and condensation, refrigeration. It's not, it wouldn't be efficient on a large scale, but bringing that concept, that idea of taking water out of the air itself is something that we'd like to bring to more of a terrestrial focus, especially in areas that are high humidity but low freshwater and groundwater availability, such as parts of Africa, the Middle East, and even Asia. So I hope that addressed your question.
Okay, no, thank you. And I'll just shoot one more question at you before passing on to my colleagues. This one is to do with outreach. Now, your outreach methods seem to be very internet focused in terms of how you get to the people that you're trying to talk to. Now, that seems like a very first world focus. How do you reach the people who don't have access to internet, who still have, who still are significant stakeholders in the water management? You identified that the water management chain doesn't necessarily have to be at government level. It can be at the user level or at the implementation level.
So thank you for that question, and to answer that question, I would pass the floor to.
Okay. So I would say the first two, specifically the first one, are very internet focused. There could be an argument for the second one, but I'll focus on the last two. For the innovation prizes in technology, that's fairly international, and I don't think has is contingent on internet access even. The fourth one specifically has lots of global possibilities for implementation because it's completely based on organizing activities. Like, I can actually give you a specific example, an idea that I had. So the framework of Guy Liberté, who takes photographs and then raises awareness about water issues. In Jordan, for example, the surface is incredibly dry. But if you go beneath and you go into the crevices, there's a substantial amount of water that most of the population doesn't know about. There's also a significant photography community there. So if you had photographers go in and take photographs and then have a form of exhibition, it would be, I mean, all it takes is a camera, and you raise a lot of awareness. So that's just an example.
Okay, thank you.
Thank you for the question.
First, thank you very much for the presentation and for all the work you did. And I saw that you made a lot of progress in the presentation since the couple of days. So congratulations to all of you. Congratulations also to all the workers there that spend days and nights on this topic, of course, of big interest. I don't want to ask too many things. My first question was very close to one from Professor Osborne on the scalability of technologies, space technologies, because you have probably also to take into consideration new or up-to-date technologies not issued from space, from space technology in general, which could be developed also to help. So my question is still, I'm sorry, on outreach. Because I think you made a very good job in trying to open this big question to the population and to the public. I would like to ask you the question how to reach the very top level decision makers in this world, to have them more aware about the space potential for this particular issue. And as you know, there are a lot of important conferences and meetings coming up before the end of this year. So how to have the space technologies and space management possibilities involved in the final discussions at the top level?
Thank you for the question. And the question lies on how do we reach the top level, the politics. And that's.
So there, again, are many components to this question. First of all, again, you have to think about what is your top level of management. A big issue in the Palestinian-Israeli sharing of water, for example, is that your Israeli management is very much, maybe what you mean by top level, it's very much corporate, very much governmental. Palestinian-wise, top level is the individual. So I guess a really good framework, perhaps, for answering that question is looking at the Indian system, where the Indian Space Agency is in close contact with the government, and they feed information to the Indian government. The Indian government actually has a system where they distribute that data to the lowest level water manager, which is the village resource centers or leader. And that data is distributed then to farmers. Another thing you might be getting at is, in the US, for example, there is a disconnection, like in California, between what NASA knows about the water situation and policy. You have some people, like James Flamma-Giletti, who actually has an active voice in lobbying Congress to make changes, but from what I understand, is not effective. So that is a huge challenge still.
Thank you very much.
Thank you.
Thank you so much for your presentation. Congratulations. It was a very, very, very good presentation, really. It was quasi-professional presentation even. And it was really international. Thanks a lot. Of course, you know, I'm a very bad guy and I have 1,000 bad questions. No, I wouldn't like to kill something. I have two very, very simple questions. Question number one, first half of your presentation, you mentioned about multi-nation problem. And all second part, multi-countries. Is it equal or not? At first your presentation, have a look. Nation, nation, nation. Second, 130 countries. If it's the same, in that case, what's about telecom? Telecom, you mentioned, it's some kind of about 130 countries plus some kind of private entities which participated. Is it the same between nations?
Thank you for that question. So the question is whether multi-nations and multi-countries, it is used interchangeably, basically.
Thank you, Tolerenko, for the question. Essentially, when we talk about nations or we talk about countries or we talk about states, we're basically talking about those entities that communicate between each other when it comes to sharing water. So, for instance, you can have nations within countries. I was just given the example of the Ukraine. But you can also have different smaller groups within countries and within nations. We decided to look at the top level, and that was basically countries or nations that were defined by international borders. Purely because at the lower fidelity level, when you're looking at smaller groups, and obviously there's conflict between smaller groups within countries and nations, it gets very hard to define where those exact boundaries are. Even at the international level, deciding where exactly the line is very difficult. But for our presentation, essentially nations and countries, there's very little difference, at least for our interpretation.
Okay, so first part is, and second part is practically the same. Okay, I only didn't understand why you try to use different definitions. Okay, second question, much more difficult. I would like to enlarge question of Dr. Osborne about scalability of something. In your presentation, you did not put even one word about financial aspects of everything. So how can we provide a scalable something from space? Well, let's suppose we have now International Space Station. You can ask our colleagues from NASA how it's costly per year. Okay, per 6 people. Now we would like to scale some technology on billion people. In that case, do we have some problems with this scaling or not?
Thank you, Professor, for the question. So the question is on the financial aspect of the scalability of the technologies that...
Thank you, Dr. Tolerenko. That is something we did address in the report. We didn't go into extreme detail, which is why it didn't show up in the presentation, given our limited amount of time. We do have a small example of scalability of a space technology, but you're right, to scale something from the ISS where you have 6 people to even a small community that might have 60,000 people is something completely different. And that's where you saw at the very beginning we had those overlapping Venn diagrams between the space and water community. That's where that interaction can work both ways, where the space community might have a really great technology, a really great idea, but water management, specifically in the engineering field, already knows how to address that large population need. And that's where you can have that overlapping of experience and knowledge being very beneficial in both ways. So I hope that addressed the question. Right, and that's where I won't speak for the whole world. I have a very U.S.-centric perspective, but I know in the U.S. a lot of the water management is done at a civil level. It's done by the government, and most governments are not profit-driven. They're there to serve the people. So that's where you do need to be cost-effective, but you don't need to be a profit-driving industry. So having a better technology can actually be more beneficial than if you have privatized water, which is something entirely different. So, thank you.
Thank you.
Thank you very much. I enjoyed the presentation very much. Well done to all of you. I had a specific question. I don't know if you can pull up slides at the moment. But it was a sketch of the world and the usage of water per capita.
Yes, yes, in the engineering section.
it left me rather intrigued because I think the UK, which is where I'm from, was the same colour as many other places that have a very big water shortage, but rains all the time in the UK. So I was just wondering, that's the one with the pink. Thank you very much. Yeah, this is what you believe the state of play right now. Did you look at all at the population growth, projected population growth, to see where maybe specific tensions will go? You obviously showed us some examples like the Nile area, and but did you look into the future population growth to see where this might go in the future?
Thank you for that question. The question is whether we saw the populational growth aspect to affect to the global fresh water situation. Sorry.
Thank you very much for the question. Okay, some sort of a consideration like that has been done in the literature review in the first period when we did the global survey, and much more example of potential conflicts has been addressed there. And I can give you one idea: is the Southeast Asia Mekong River, large population growth, even if it's not a dry area right now, but that was a very potential stress area and recognized as a potential water conflicts region for the future. This type of consideration have been done in the beginning when we did this global survey. Then here we just give some glimpse, just to give an example of right now the situation is there. As Shreya was mentioning, also the population growth effect. I mean, this futuristic approach wasn't implemented in this analysis. Or more right now, 5 years from now, no more than that, even less probably. So yes, this kind of consideration are in the literature review. There is something like that.
Okay, thank you very much.
But it's not a key point. Thank you.
Thank you very much for that.
I'll just pass on this message in the middle of the questions, which is just from the Marshall Space Flight Center team, a team at NASA, the Regional Visualization and Monitoring System Survey, want to express their appreciation and say that you did a great job. Because of the technical difficulties at the start, they're not going to send any questions in now, but they'll send them in when they've had a chance to review the slides, which we've emailed them. Okay.
Thank you.
Yes, this is, I'm Steve Brody, the ISU, from the ISU North American office. And first I want to congratulate the team. I found the organization very, very well done. You have pardon the pun, but you have whet my appetite for the greater detail that I know must exist in your 100+ page final report. Picking up again on Jean-Jacques' comment about how do we get to decision makers and people that really need to hear the message, but also not only hear the challenge, but the fact that you're offering a window of the space community as a potential help to the problem. I know because of my personal involvement with ISU that you will be, I expect, presenting at the IAC, the International Astronautical Congress, in the fall. That's true, right?
Yes. Yes.
And also,
right.
We have efforts where every team project gets the article written in Space Times magazine, which is widely distributed in the States. And one other, I know from my NASA colleagues who are supporting this, that I've already been asked if I can work with somebody from the team, and of course, Professor Zeros, on arranging perhaps a presentation by one or two people in Washington, D.C. of the results for some of the U.S. government people who will be interested, including the U.S. State Department, which is also generally interested. But to pick up on the question, what have you specifically identified other fora, either within the UN, within other events that are occurring within the very near term, the next 6 months or a year or so, where you want to make sure that your report is known, that the fact that you've done this? Is there something that you have, sort of a checklist of, we want to get the message to these people or these organizations or these conferences beyond the ones that I've just mentioned?
Thank you very much for that question. So the question is how do we outreach our ideas in the top level to the politicians, and what have we come up with specifically?
As I talked about, World Space Week is of interest to us, and it's my understanding we've submitted some sort of proposal to that. And we did talk in person with someone involved in it. The answer on that was that the subject perhaps is too specific. They're more interested in a sort of maybe environmental themed topic, but water could still be a part of that. That's all the information I have on that one. In terms of conferences, actually more toward the beginning of the project, we looked very closely at even perhaps having, because we represent so many different places, and after this we're going to scatter, looking at presenting the paper at conferences within the next coming year. What I have to say about that is incredibly contingent on individual funding. So it has been thought of, but the practical implementation of it is still to be seen.
Have you identified ones that you feel would be most effective if you could?
Some have been identified, and now that more people know where they're going to be in the next 6 months, I think, yes, even more could be identified. Thank you.
Yes, so that is the question. I hope it answers your question.
A minor follow-up. Is it not true, I believe I heard earlier in the project, that it's already known by UN-USA, the Outer Space Office of the UN? They know about your project, and did they request or invite that they get first crack at making sure they know when it's available so that they can take a look at it?
Yes, so the question is on whether we presented at the UN.
That's an easy question to answer. Yes, we did a presentation at UN COPU's sub-technical committee. It was really good. It was very well appreciated. We have a good contact list, especially with the former Austrian ambassador, Walter Lieschen, and he's the one who started all the UN talks on water. And we are really in personal contact with him, and also some UN contacts at UN also. They're just waiting for the final revision of the report. And that's it. We are in a very good tight with the UNESA and the UN COPUs, for sure.
Thank you very much for that. Please, Professor.
Very, very well presented presentation, and it showed enormous evidence of hard work, hard graft, and consideration. Now, how many of you know who Jim Burke is? Okay, roughly half the team. Now, in 2005, at the SSP session in Vancouver, I remember having a discussion with Jim, and Jim was complaining at the time at how inexpensive, in his opinion, gasoline was in the United States. And his contention was it should be a lot more expensive, and if it is a lot more expensive, that means people will use less gasoline. That's going to be better for the environment. Now, could you perhaps share this idea in the context of water? We all take it for granted, and yet some countries are completely devoid of water. Surely it could be priced to make people use water sensibly.
So the question is relies on the privatization of water resources,
Charging
right?
people for water.
Charging people for water usage. Yeah, charging people for water usage. So for that, I would like to pass the floor.
Well, not charge people for water because we want to make water common good. But one of the ideas of Ambassador Walter Lieschen was to actually outreach countries by trading gasoline, by trading oil with water. So how to make them listen, the high-level politicians, to listen to our project, Well, you gotta trade with something that's in the same level of importance. And oil was his first idea, You trade oil, you trade service. And then you make, water and gas, oil, let's say, trade in an equity manner. That was his main idea, that we base ourselves here too. I hope I'm answering the question.
just to build upon that, we have had cases. That's a very sensitive topic, because we have had cases in which people just hear the word corporation, just hear the word paying for these resources that they can fetch. And that is the problem. To a managerial level, I think you can, and we have a section in our report of public-private partnerships for the management. But when it comes to the water resources, we believe it's not. We have a case in Bolivia, which was a prominent case back maybe 10 years ago. Yeah, yes, and it's a case in which the government with some corporations try to privatize the water, and then the population was rise, and they wouldn't stop protesting until that was cancelled. And they've lived off the land, they've lived off of that, and in that aspect, to a managerial level, I think it could be done, and it has been addressed in somewhat in the presentation, in the report. But to the privatization of water, I think it's too sensitive. Yes, just.
Thank you very much.
Okay, thank you very much, and congratulations all the team. My question is, maybe the time is limited, so the short question, you are listing the kind of model agreement like ISS or ITU maybe, but there are so many agreements, non-space agreement, I think. But the keywords presented, they are just the global common or common heritage. Except those two things, is there any advantages the space agreement has? I'm not so sure about. I'd like to hear the team opinion.
Okay, thank you. So the question is whether we have some advantages in a space agreement compared to agreements that have not been an outcome of space.
I'll try again. The advantage we have is much more with procedures. So we want to use the same procedures that were taken that were enabled, right, the constructions, let's say constructions, the finish of the current agreements we have, such as the MOO one, even though it was not very adopted by all nations, and the outer space treaties, and also the ITU, and use the same procedure, the same framework to water. So that was the biggest advantage we have, although, like as the Moon Treaty, for example, would not sign.
Okay. The question regarding that kind of procedure, but where water matters, we would have so many conflicts.
Right.
So those conflicts are usually not easy to solve. So those things are all the same as in space, I think. Depending on the case, but anyhow, currently we are operating International Space Station, the negotiation conducted almost maybe 10 years or so, more than that. So the agreement is agreement, not easy to reach. So my opinion is such that. So but could be not easy to say a model. My opinion. Okay?
Well,
thank you very much.
Well, it's not easy, it's for sure. That's not easy. But for example, if you look at the ISS, for example, although you see the political scenario we're living right now, it's not easy, and it still has been working. And that's the main point why we think this is the best practice, the framework of space.
My suggestion is that maybe the Fuan said some case regarding to Bolivia, maybe the team could have create a kind of model, the scenario, the integrated scenario, how to apply those scenarios to each cases, like for some specific basin, you can establish a kind of organization or association, and then such kind of thing. So it's possible to to make it clear how to apply these recommendations in actual work.
Yes, I'll just pass down to Martin to answer quick.
Okay, thank you for the question. There is actually a very direct answer to that question. Although we have done a lot of research and we are from a lot of different areas in the world, our team really feels that we don't have the expertise to say to a particular water manager how exactly should they act in their region. However, what we do and what our report is intended to do is to give them recommendations based on those three scenarios. So if they identified themselves in one of those three, then there are those best practices for those scenarios that could help. Thank you.
Thank you for that. Hope it answers the question. Professor Servos?
Yes, thank you very much for this interesting presentation. I also enjoyed it. I think it was a good effort. Nakahara-san took one of my questions away, which was the feasibility of why, which I think is something that many people from audience that have not been intrinsically linked with your project would have. Why didn't you apply this to specific examples, to the examples that you mentioned at the very beginning, for example? And I think it's a good point that you raise in terms of also avoiding some politically sensitive situations there. So I will take this this point further and ask you a question with regards to slide number 73, please. And in slide number 73, you're suggesting an ITU model of management considered for international water resource management. And if I'm to compare that with slide number 79, must consider how to effectively appeal to the water market. And I recall saying there that you don't know who the manager is and you want to sort of refrain from making those suggestions. Most of the solutions that you provided are complementary to each other from scenario to scenario. But the suggestion that we treat water as a good that would require a global management system to undertake it is somewhat conflicting with that, with many of the other solutions that you're suggesting. So I think you should pay a little bit attention to that. If you have some comment to make to this, it's a rather non-simple subject. It touches also upon a little bit the point that Professor Tolyarenko said, but it is not an issue if you're advocating this, if I understood correct, that you're advocating for an ITU-like system of global water resource management, which is what I think slide 73. So if you'd like to clarify that.
Yes, thank you. So it's on the ITU managerial aspect.
I'll be really brief. Essentially, the ITU is really complicated, and they require hundreds of people to all agree on something before they get anything done. The main point with the ITU that we wanted to refer to was the way that they look at radio spectrum and orbital slots. Mm-hmm. So, and that more refers to the way that we feel water should be treated and understood as a limited and non-renewable resource. We only have so much, and there's only so much to go around. And I feel that, well, I think the team feels that for the ITU model, everyone understands that, and that's why they have to agree to work together. When you're on a local level or at a national level, you think the water that's flowing into my country and from this river is mine. I don't need to worry about anyone before it flows out afterwards. And their view is very limited in terms of that scale. I think the suggestion is basically to look at it as a global resource and to understand that there is a water cycle and it doesn't necessarily all happen in your own country. It flows in and out and across boundaries. So that's the gist of why we introduced the ITU.
Okay. No, I thank you very much for that. Yes, I understand that, but it's not my fault. So I just have a quick minute to finish with that. Thanks, Chris. So no, thanks very much for that. And I think this also points out to the fact that these externalities are also perhaps would address the question of why in petrol consumption, for example, where you have negative externalities, as opposed to water, where you have positive externalities, you might want to consider different policies. But I think if you're not touching about sovereignty and governance issues, I think that should be okay. Thank you very much. Sorry about the delay, Chris, but I was trying to finish this up.
Thank you very much for your attention.